So this set is basically working on successive derivatives. So we've already been working on how to do the first derivative. So this introduces the concept of being able to take the derivative of that, and the next one to take the derivative of that, as well as introducing some notation that can go with tracking those derivatives. So here's the first 4 sections. I'm just going to go through them, talk them through as I go. So the first derivative for this one, we're going to use the power rule. So this will become 10x to the 9. Second derivative, I need to do that again, so I've got 90x to the 8. Third derivative, multiply that out around again, I get 720x to the 7. For this particular one, my first derivative will be 15x to the 4. My second derivative will be 4 lots of 15, so that's 15, double that's 30, double that's 60. X, 1 of the power is 3. And my third derivative, 3 sixes, 18 times 10 is 180 x squared. This is a linear function to start with, so I've got f dash here equals just that minus 3 component. My second derivative of the constant function is 0, and then we can't take the third for that one. My first derivative here is power rule, so I'm going to go 2x minus 3. From the quadratic to the linear. The next one is then going to be a constant, and the third one down to 0. On to the next page. We again want to do the first, the second and the third derivatives for these ones. So here we have power rule again, 12x squared minus 2x. We do that again, we get 24x minus 2. And then again we get 24. This one is really important to note that we're starting with a decimal, and as the power rule works, we need to take 1 off that. So my first term is going to be 0.3x. Now 1 off this is going to be minus 0.7. Most common mistake there is to make that minus 0.3. And what we do next is then we multiply this out. And what I'll get there is negative 0.21 x to the power of minus 1.7. And now the next step is to go minus 1.7 times minus 0.21, and what I actually want to do that is 0.357 x to the minus 2.7. So just working with decimals, take your time on the multiplication and watch the change of sign at the front. For this next one here, what we have is minus 1x to the minus 2. You can leave it as index form because that's how I was given it. Next one can become positive, 2x to the minus 3, and the next one negative again, minus 6x to the minus 4. Note the minus 2, minus 3, minus 4. Before I start this one, I'm going to rewrite this as a power, so I can then use my index rules to use the power rule. So I've got minus 2x to the minus 3, and then I want to leave room to come back and write it as a fraction because that's how the question was given to me. The second derivative will be 6x to the minus 4. Again, I'll come back and write it as a fraction. And then the third derivative is minus 24x to the minus 5. Now going back to write them as fractions, this becomes minus 2 all over x cubed. This one, the 6 stays where it is. That is over x to the 4. And this one is minus 24 over x to the 5.